All right, good evening, everyone. Welcome to another super fun episode of Moon-topia. Happy Martin Luther King Jr. Day to everyone out there in the US and really just all over the world. I'm Irene Pease here with the Amateur Astronomers Association of New York. You can find out more about AAA at AAA.org. Follow us on the social media things at AAADOT. ORG. So, as I said, it's another episode of Moon-topia. So, we've been doing these kind of once a month, checking out some of the amazing moons, these beautiful satellites that we have all over our solar system. Last month was kind of the main event, but we're just going to keep rolling with this until I get tired or we run out of moons, whichever comes first. And so, tonight we have Act II. Midsummer Night's Moons. So we're going to be taking a look at some of the moons named after Shakespearean characters, and that's kind of the theme. That's the whole theme. That's why we call it Act Two. Quick disclaimer: I'm not really big on literature. I'm not a literature person per se, and most of what I know about Shakespeare I know from looking at the Uranian moons. So there you go. That's what you're dealing with tonight. For the visuals in the background right now, we have open space, and we'll be coming back to that in a little bit. And in just a second, we're going to pop over to Stellarium. So you can find all those visuals at their respective websites, OpenSpace at openspaceproject.com, and you can download Stellarium at stellarium.org. So to kick things off, we do like to take a look at just what's happening in the night sky. Here we have the beautiful skies, super dark, gorgeous mountain night skies of Brooklyn, New York. And in case you've been to Brooklyn or anywhere around New York City lately, it's not actually that dark these days. That's okay. But we do have a lot of bright things in the sky. So this is set for now, 7:30. Yep, that's now. It's dark, getting dark a little bit later. But it is dark now. We have a bit of a moon out. That's not the whole moon. If we zoom in a little bit, we have a nice crescent coming along there. So that's a moon. And there's one moon down, several more to go tonight. And then up here we have a couple planets, and this should look kind of familiar because all last fall and late summer, I was going on and on about Venus, sorry, not Venus, the other planets, Jupiter and Saturn being really close together in the sky. So now we have that kind of happening with Uranus and Mars, not nearly as spectacular a show, but kind of in conjunction. I'd say it's worth checking out because I'm me. So Mars, very bright. It's the big bright red thing that's really high in the sky. Kind of can't miss it up there. There is another bright-ish, reddish thing that's a little bit further to the east these days. If you're familiar with the constellation Orion, it has a belt that points up to Aldebaran. That's a star in the constellation Taurus. And then there's the armpit of the giant Betelgeuse or Betelgeuse, however you want to have fun with that name. So those are kind of reddish stars. They might twinkle. Mars is going to be a little bit different. It's going to be a steadier light, but it's just still that kind of orangish hue. And if you follow that in telescope or binoculars, you'll see it kind of gliding near this little bugger here, Uranus. So I think in the next night or so is actually going to be closest pass. So if I kind of center on Uranus there, yeah, I think it's tomorrow night. So the 19th, 20th, you have the moon, our moon, kind of close. So probably won't see a whole lot of moons here with this kind of conjunction. Mars's moons are pretty faint. You need a pretty good-sized telescope and or a little bit of time-lapse photography to see those. And same with the moons of Uranus. But you can see our moon, which is always glorious, right? And just know that there are more moons around Mars and Uranus. And tonight, mainly we're focusing on the moons of Uranus because Uranus is the planet that has moons named after Shakespearean characters, etc. So that's where we're headed. So if you've never seen Uranus in the sky, You can use Mars as a marker. I usually say use the moon as a marker, but Mars is going to be even closer. It's a little bit fainter, and it's going to be there for a couple days, not just whizzing by big and bright and kind of blinding everything else out of there. So Mars, Uranus, check them out in a telescope or binoculars if you have them. Tonight, tomorrow, the next night should be a fun thing. So moving on over to the open space. So that's our sky. Back to our open space, getting out there into space. That's not Uranus. That's not a moon. But I did want to just start off talking about Uranus as seen from Earth. So not just Uranus, but really the moons. So Herschel, way back in the 1700s, 1787, basically actually January. So a couple hundred years ago and change tonight, this month, he actually found two of the moons, the first two moons that we knew about for Uranus. And no one else really saw them for a while, a bit after that. But if we jump through time, I'm going to jump through time. The first time we got a really, really good glance at the moons was 1986. So all you kids who know what happened in 1986, just gonna cheat and jump over here. Here we are. So now we've jumped through time and space like you can with open space. Very open, very jumping. And here we are following one of my favorite missions that I kind of raved about in one of the AAA classes last week. This is, oh, look at that. Fancy meeting you here, Voyager 2. So this is where Voyager 2 was in 1986. January 1986, actually. So this is very January time. Actually, sorry, Herschel, that was May. So, but Voyagers went by in January. I think Herschel was actually observing them in May. But we're going to be just kind of following Voyager's little journey past the Uranian system. So even if you kind of imagine just this view without Voyager 2 there, you can see this is kind of moving in the plane of the solar system. I think I turned off. Yeah, so if we turn on some of the orbits of the planets, there we have that kind of teal orbit. That's the path of Uranus around the sun. And then out past that, the darker blue line, that's the path of Neptune around our sun. And so the plane of the solar system is, kind of going across from, what would that be, downstage left to upstage right. Trying to throw a little bit of theater in here. Probably will mess up my left and my right because I do anyway. But we see Uranus kind of with some of its larger moons. You can see the paths of the moons. You can't see the moons themselves at this point, but kind of see it as like a big bullseye. So that's more or less what Herschel would have seen, this nice bullseye in the sky. It does kind of change its orientation relative to us. So if I just, we're going to focus on Uranus for just a moment. And if you imagine at some point from Earth, we would be seeing the system like, yay. And so with those moons going around it, we could have actually an occultation where one moon passes in front of another moon. So when we see Uranus and its system from this view, that's when the system is going through an equinox. Voyager passed through during the southern summer, so we didn't get a view of any of the north sides of the planet or the moons, but we got maps of quite a bit. So let me just jump back to Voyager 2. Voyager 2. There it is. And and see if we can't just kind of follow it through the system here. That was kind of the goal for the first part of the evening. Oh, Voyager. Okay. So kind of carefully choreographed. We're going to not go in real time, but let's play through at, I don't know, several minutes per second, about 30 minutes per second to start off as we come in on the system. So you can see some of the inner moons moving around there. So 5 major moons, and the ones that we're going to be focusing on are the 2 outermost moons. Speed up time just a little bit more. And then one of the inner moons that isn't actually shown in here yet. So the moons, pretty much all of the moons of Uranus were named after Shakespearean characters, except for 2. Technically 3, but really Ariel is a character from Alexander Pope as well as from one of Shakespeare's works. So we're going to claim Ariel for Shakespeare, even though it kind of wasn't, that was not the intent. And the 3 moons that we're looking at tonight, so we have Titania and Oberon, and then way in here somewhere we'll see Puck. Those are all from, you guessed it, probably other people more familiar than myself, Midsummer Night's Dream. So hence the title tonight. So I'm going to slow down time a little bit here, so we just kind of like zip through the system. So Voyager actually discovered a few more moons of Uranus. Between the 2 missions, discovered several moons from all the giant planets. But Puck was the one that it was able to kind of re-choreograph, and they were able to program the probe to actually take a few directed pictures and specifically try to image Puck. The other newer ones, not so much. They were just kind of like in the background. But Puck they tried to image, and so we'll see the super awesome ridiculously clear high-res image that we have for Voyager 2 from 1986 of Puck in a little bit. But I just like seeing these kind of flybys of the missions. And really, if you want to, shameless plug for the missions class. So there's another class that we're running at AAA that I may or may not be teaching. It starts tomorrow. It's about current missions. So Voyager will cover, because it is a current mission, the Voyagers are still going, but not look past their way outside of the solar system at this point. So here we go, zipping by. So the cameras are kind of on this end, and then this end is like other instrumentation, power, and magnetometers. But as it goes along, you'll see it kind of like aiming, catch a couple moons there, catch the planet itself as we go zipping by. I guess it's about half an hour per second. Take a picture of Puck, measure that magnetic field. So we learned a lot about the Uranian magnetic field, which is going to be important in a moment, and a few more pictures of whatever, actually probably other instruments sensing at this point, since not a whole lot of visible light, but there were also some infrared and UV. So that's the tour. That's what we saw way back in 1986. And there have been some instruments and chances for other detection since then, but those were kind of the closest pictures that we've been able to take. So I'm just going to go ahead and refocus. We'll start on the outside and kind of work our way in. So jumping first again to Oberon and all its glory. So Oberon, second largest moon of Uranus. And this one's important. It's going to be different from the other 2 in that it's actually sometimes outside of the magnetosphere of Uranus. So that was one thing that Voyager was able to measure, was learn more about the magnetic field at Uranus. So the large moons, so again, Oberon's the largest, and then going, well, actually remember them from inward to outward. So way in there you have Miranda, Ariel, Umbriel, Titania, and Oberon. So Oberon and Titania have a few things in common. One, I don't have the maps of them pasted in here because, again, we don't have full maps. We really only caught, again, the southern hemisphere, and that wasn't even an all like really good resolution. So maybe 25% of it in high res, and people have kind of guesstimated a lot of the rest of it. But all these moons are tidally locked. So the large moons, I should say. So Oberon and Titania, both tidally locked. But Oberon, outside of the magnetic field for a big chunk of its orbit. So why is that interesting or important? Well, it turns out that there's a lot of reddening. Like, so these moons have a bit of red hue on them. They're not very reflective. They have a low, what we call albedo, not very reflective, kind of absorbing a lot of light. And for the inner moons, you have one side that's more red than the other, and because Oberon isn't exposed to these streams of plasma particles from inside of the magnetosphere of Uranus, it doesn't get this buildup on its lagging side. It has more of a buildup on its leading side. So it is the reddest of the major moons, probably has an icy mantle and rocky core. Maybe a liquid layer near the core, but it's not super dense. It's only a little bit denser than water, and so yeah, not too terribly not too terribly dense there. I do have a super fun picture of it. Super fun picture. Yeah, that's our super fun picture of Oberon. And so most of the features here are named after more characters from Shakespeare plays, mostly men. So you have the huge crater, Hamlet. So it has lots of craters, and it has these chasms, these kind of rifts in it. So craters from impacts, and you can even see kind of these impact marks, these streaks from some of the newer craters. I think that might be Hamlet over there. Sorry, this one was Hamlet. This one might be Macbeth, but the big one is Hamlet. And then there's a big rift up here. So those rifts, it's not super active these days, but early on when it was forming, the first couple 100 million years or so, the different layers were doing different things. So the outer part was cooling and the inner part was still expanding as it cooled. I guess that's what you get with ice. Not sure if there's another reason for that, but that actually caused a lot of these cracks and stuff in the outer parts of Oberon. So the whole thing isn't really huge. It's only about 760 kilometers in radius. And I think that was most of the exciting stuff that I had about Oberon. More craters on the leading side. So I believe that's up here. And redder on, I believe this would be the lagging side. And then for the others, that's kind of reversed. So Oberon, one of the fairy kings. So pretty much all of these were kind of named after like fairy, airy, kind of flighty things of the air creatures. I guess because I know something about Uranus in the air that I didn't really understand because I don't know enough Greek mythology. But that's our Oberon. Hello, Oberon. So moving inward into the region where there's more magnetic field, see if I can find where the other moons went. Somewhere. There they are. Other moons. I want to check out Titania next. So also a fairy, I believe. Fairy king and queen. I don't know. Again, it's not Shakespeare, not my thing. So Titania. In we go. And also, again, don't have the whole map of it, but you kind of get the idea. It's a little bit closer and close enough. And Titania is the largest of the Uranian moons. So Titania's largest, Oberon second largest. And Titania did a fun thing back in early 2000s. I want to say 2006. It actually occulted a star. So that means it went like right in front of a star. So if I line this up just so, right? So from Earth, we basically see it kind of pass in front of a star, so it blocks it. So that's really handy for one, narrowing down exactly where it is, so it's ephemeris, and we can tell, we can get another measurement of kind of its radius. And if it has any kind of atmosphere, we can kind of use the starlight and say, oh, is there anything exciting happening to the starlight as it's, close to either side of our little moon here? And do a little bit of analysis, say, are there gases near it? Is there an atmosphere? And it turns out the answer is maybe. I'm going to kind of wave my hands and kind of shrug and say, maybe. So a lot of water ice as well as dry ice, so frozen carbon dioxide that has been detected with infrared spectra on the surface of Titania. And because of the presence of that dry ice, that frozen carbon dioxide, it's thought that there might be, yes, maybe a very, very thin kind of trace, maybe a little bit more than trace, carbon dioxide atmosphere. And wouldn't that be exciting? Right? So even on these freezing cold worlds, like they're, less than 100 Kelvin. So it's a little bit nippy out there in that part of the solar system. There still might be some kind of sublimation happening where you can have like gases near the surface of these. So also, again, similar to Oberon, probably some kind of water ice mantle and a rocky core. Lots of reddening, lots of canyons and scarps. Not as much cratering as Oberon. Oberon's more heavily cratered, mainly just being further out there. Stuff isn't going to be deflected by the magnetic field as much. But here inside our magnetic sphere, it is exposed to more of the magnetic spheric plasma on the trailing side. So the trailing side is going to be darker. And that's true for all of the other large inner moons, all these large moons in here. So like I said, also a lot of craters and chasms. It doesn't have quite the degree of chasms, I don't think, as Oberon. But we zoom in and get our super fun picture of, there's Oberon, Titania. So isn't that lovely? I don't think this is colorized. This is like black and white, but it's higher res. So you can kind of get a sense again of like the rifts and just kind of like the positioning of Voyager 2 as it went, zipping by these. And I marked off. So we have this huge crater, Gertrude, up here. And then there's an unnamed basin. I forgot what that's about, but I wrote it down. So look it up. It's pretty interesting, apparently. I just forgot exactly why. Huge chasm that cuts across it. And then down here, I think it's this blob here, that's Ursula. So again, here we have like Shakespearean characters for the names of the surface features. And they're all women here because now we're at Titania. So Ursula Crater is kind of interesting. Most craters, like if you look at the moon, there's like a big hole in the ground, right? And maybe you have like ejecta and rays coming out and stuff. And then there's like a mountain peak in the middle. Pretty standard. Well, there's a kind of this weird thing happening at Ursula where instead of a mountain peak, it's actually an indentation. And how did that happen? Dunno, okay? But isn't it interesting? So having this kind of pit in the center instead of a peak. So again, Gertrude's pretty big. Gertrude's the largest one. It's about a quarter. It actually takes up a quarter or so of the whole moon. So what did I write down? Yeah, 320 some odd kilometers across, and the radius is only like twice that. So it's pretty big. Pretty big hole on a not super huge moon, but largest moon of Uranus. So that's Titania, also a fairy. Really lovely. So last but not least, we're going to kind of zoom out, look back in here towards Uranus and all the wonderful things whirling and swirling around Uranus. So remember, these are their south poles. So this isn't east or west, this is south. And then I mentioned the leading and lagging. So this would be the leading edge and the lagging edge that it came from as they're going around Uranus. So Uranus does have that magnetic field strong enough to have aurora and fun things. And it just needs to turn on the trail for Puck. There it is, right? So you see its way in there. There's actually a whole series of moons that are in there, but they're all, pretty small. If we go ahead and just kind of center on Puck. There we go. So all well inside of the smallest orbit, the closest orbit of the closest major moon, Miranda, in here. So there's several. There's actually another moon between Puck and Miranda. Don't ask me which one. But Puck is actually inside of the ring system. So now we're not really seeing a whole lot of rings of Uranus here, but again, Uranus does have the second most extensive ring system in the solar system after Saturn. So really cool rings. Puck is maybe slightly oblong, mostly spherical, but we try to get a measurement, figure out if it's a little bit oblong. And where's my Puck? So yeah, Puck only about 81 kilometers in radius, and it's really zipping around there. If we actually turn on, see if I can turn on real time, you can see how quickly it moves. It actually orbits around Uranus in less than a day, just about, if I do math in my head, 18. Yeah, about 18 hours it orbits around Uranus, whereas the outer moons take about 9 and 13 and a half days respectively. So Oberon, way out there, takes about 13 and a half days to go around Uranus. And Titania takes just short of 9 days to go around Uranus. So really close in here, has a nice view. We have a nice view of the aurora, and an interesting view being between the planet and the rings, which again, they're darker, so we're not quite seeing them in here. But the other fun thing was the Puck was actually one of the moons discovered, I think I mentioned discovered by Voyager 2. And as I mentioned earlier, we got this lovely image of it. So I just want to share that real quick. So there's Titania and all her glory. There's Puck. So yeah, it basically has 3 named craters. I think this might be one, and this might, and maybe this thing here. But yeah, we tried, all right? So it was kind of a recent discovery, last minute reprogramming, and that's Puck. Hey, little Puck. All thanks to Voyager 2. Thanks, Voyager 2. And it actually, this huge crater, this big blob over here, is again really large for a very small moon. So again, it's only about 81 kilometers in radius, and that crater is over half of that. It's 45 kilometers across. So I'm not sure exactly how they could tell that, because I can barely see a crater there. But I guess if you have some other instruments, maybe not just the cameras, have a quick aside and measure that on Puck. So those are your Shakespearean moons, a couple of them anyway, just 3, because I feel like 3 is kind of enough for one episode of Moon-topia. But again, all of the Uranian moons, except for 2, were named after Shakespeare characters. So those are the 3 that are from A Midsummer Night's Dream. We also have moons from The Tempest, King Lear, Hamlet, The Taming of the Shrew, etc., Othello. I don't know, some things I haven't even heard of. Much Ado About Nothing. So Much Ado About Moons. Maybe we'll do a Much Ado About Moons and talk all about Margaret, if I can get a lovely map of Margaret. So that's my attempt at our Shakespearean Moon-topia. Thanks so much for joining. We'll just have a quick epilogue. Again, I'm Irene Pease with the Amateur Astronomers Association of New York. Check us out, AAA.org. Take a class, join us for a lecture. We have a lecture again next month. We have meetups and fun things in our astrophotography group. Thanks to the programs we use for visuals, Stellarium you can find at stellarium.org, and OpenSpace you can find at openspaceproject.com. Thanks so much for joining me, everyone. Have a good night. Clear skies. Be safe out there.